Hello everyone, welcome to Geeks for Geeks. So let's talk about today's problem. Our problem name is find length of loop, right? So let's first understand the problem. So our problem said find given the head of the linked list, right? Determine whether the list contain a loop. If the loop is present, we just have to return the number of nodes in that particular loop we have, right? If there is no loop, just return me zero in that case, right? That's the case what we have to do, right? Okay. So in that case, the node point is given to you. C is the position of the node, which is the next pointer of the last node of the linked list, right? If C is 0, then there is no loop, right? Okay, so let's see how we can solve this problem. So this is the example which is given to us, right? In this particular example, my value of C is 4, right? It means that your loop, your ending point will be connected to fourth node of the linked list, right? Fourth node of that particular link is first, second, third, fourth, right? If C is 0, it means that there is no loop. Just return 0 in that case, right? Because at the end of the day, I just want to count how many nodes we have in that particular loop. If there is a loop, right? If there is no loop, just return 0 in that case, right? That's what we have to do. Okay. So how we can solve this problem? So the problem is very simple. We just have to find first there is a loop or not, right? So how we can do that? So using tortoise method we can easily solve that part, right? So if you are not remember the tortoise, I just want to request, please first revise that part first, right? So in that case we just use two pointers approach, which is slow and fast, right? Okay, so in that case what we are doing is we simply make first node as my slow pointer, right, which is pointing to the head of the linked list, right? And we simply make the fast pointer which is just next of it, right? Okay, so in that case we just make my fastest head ka next, right? So my slow will be this and fast will be this, right? Okay, so in that case we just have to ask if while slow not equals to fast, right? What we have to do is we just have to run like that. We just have to run my slow pointer one time and fast pointer two times until we are not reaching slow equal to fast, right? Okay, so in that case what I am doing is the first step we just have to ask, hey fast, if there is no loop, right? So let's see that particular case first. So for example we have something like this linked list. Okay, so here we have slow pointer, right? Here we have fast pointer, right? So as we said, my slow will run one time, right? So let's run one time, and my fast will run two times, right? Fast will run two times. So here we just have to write like that. Okay, so in that case what I am asking is, okay, slow will be one time, slow will be here, fast will be here. Now tell me, can we run two steps in fast? No. So in that case my stopping case is, I hope you remember now, my stopping case for even numbers is fast ka next not equal to null, and in even odd case fast not equals to null, right? So here we simply write fast not equal to null, or if my fast ka next, right, not equals to null. In both case, right, we just have to return 0. It means there is no loop, right? Okay, okay, so in that case let's do the trial run for your odd number of case, right? So in that case if you see, let's take the small example. So in that case my slow will be here, fast will be here. Now I'm asking slow equal to fast, they said no. So slow will be here now and fast will reach to the null point, right? See here, right? This is the case for the odd numbers, this is the case of even numbers, right? So in both case we just return 0 in that case, and we simply tell, okay, there is no loop, right? There is no loop, return 0, 0 number of nodes, right? That's it. Okay, now let's see for this case how it's work. So in this case my slow will be moved here, fast will be moved two step here, right? Okay, again my slow will be here, my fast will be two step here, right? After that slow will be here, fast will be two step here, right? Slow will be here, fast will be two step here, right? Okay, after that slow will be here, fast will be one step, two step, fast will be here, slow will be here, fast will be two step, one and two, right? Like this. Now if you see here, my fast will equal to your slow, right? So let me erase this. Okay, so in this case we just reached that part, right? Now it means your while loop will complete, right? It will not return anything, right? You come back and you know that where we are pointing to that particular node, just write the count of it. Okay, so what I'm doing is I simply make the count right now equals to 1. There is one loop, one node itself, right? So in that case, after that, what I'm doing is I make fast just one step ahead of it, right? Fast will be fast connects, right? Like this. Okay, now very simple. What I'm doing is we know that we are in that particular loop. What I'm doing is I make count here 1, right? Already do that. Now simply make while loop again and make slow not equals to fast, right? Until again I want to run whole loop, right? And using that particular statement, I simply make count all the number of nodes we have, right? So fast will be one step, right? Let me write here fast will be one step, right? At the end, what I'm doing is I simply return the count, right? I simply return the count. Okay, so this is the case of it, right? In this case, we have 1, 2, 3, 4, 5, 6, 7. In that case, again, because slow remain here, right? In the first part, fast will be here. We just stop here and return the count of it, right? So in that case, we can do that. So the intuition is very simple. We start from low from the first, fast will be at the fast will be one step ahead of it. We just run the loop. If my number of odds we have, this is the case, right? If we have even, this is the case, right? That's it, right? We just have to go one step, two step. If we do not hit the condition, it means there is loop. So where I am pointing right now, that is count equal to 1. And just go one step ahead, your fast, because slow will remain there, right? In that case, we just run this loop, and at the end of it, I can count all the number of nodes in my particular loop, right? That's a simple intuition. Okay, now hope you understand. Let's code this now. So the first case is I make two pointers. Slow will be at the first and your fast will be at one step ahead. Okay, now in this case, simply I am asking when slow not equals to fast, right? We just have to run my one step and two step, right? Before that, we just have to ask if your fast equal to null or fast ka next not equals to null. If this condition is satisfied, it means there is no loop, right? Return 0 in that case. So low will run one step and fast will run two step. Okay, so when we move out of it, I just make my count will be 1 and fast will be one step ahead, right? Okay, again we just have to write the same condition while slow not equal to fast. Okay, just increment the count. Okay, and the fast will move one step ahead like that. At the end, what I'm doing is I simply return the count of it, right? That's the simple intuition. Okay, so let's see it's working or not. Okay, we have some issues. Okay, let's see. Oh, it give me 0 answer. Okay, so in that case, my slow will be at the start and fast will be at the next. Okay, slow not equal to fast, that's fine. So if fast null, fast ka next. Okay, here we just have issue. Fast ka next equal to null, right? Okay, so let's see it's working now or not. Yeah, it's working fine. Okay, let's submit and check. It's passing all the case or not. Yeah, it's working fine, right? Our code is working fine. Now let's talk about time complexity. So our complexity will be very simple. In the first while loop, what I'm doing is I simply traverse each element one time, maximum one time. So in that case, it's order of n, right? So in the second case, we just traverse that particular number which is in the loop part, right? So there is a condition when your loop will be whole nodes, right? That particular case when your c value is 1. So in the worst case, we can say that my complexity is for the first loop it traverses all the nodes, right? Okay, and in the second case there will be a loop when c equal to 1, right? In that case also we just have to traverse whole linked list, right? So in the worst case, my time complexity will be 2 into order of n. We just ignore that part. So it's order of n, right? Like that. Okay. So hope you understand the solution intuition. Thank you so much.